Hello, everyone, and welcome to today's SANS webcast, Exploring Registry Explorer. My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Eric Zimmerman, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Eric.
Hello, everyone. Thanks for joining. Today we are going to be exploring Registry Explorer. So I've put together a handful of slides, about 10, that's basically just going to give us a little bit of a feel for what we're going to be talking about. The majority of the time that we spend will be actually looking at Registry Explorer and looking at the features and loading in hives and doing searches. So if there's any questions, please post them, and then we'll be sure to address them at the end or whenever they come up, whatever makes the most sense for us as we go through here. So the first thing I would just want to talk about is just what a hive looks like in general, because that will help understand really one of the newer points, one of the newer features that has been added into Registry Explorer, and that's transaction log file support. So not going to spend a ton of time going over what a registry hive is and how it's built and how cells are related to each other and that kind of thing. If you are interested in that kind of stuff, of course, I have lots of information on the blog about that. And then there's a video link at the bottom that is a presentation I did on a lot of those internals from several years ago at the DFIR Summit. So as an overview, this is what a typical hive is going to look like. You have a header, you have a collection of things after that header called HBin, and then inside the HBins, you have cells, lists, or data. And each one of those is basically a separate bucket that you have to go through and parse. And then the individual cells and lists reference things in other places in the hive. So it's really just a collection of pointers that go around that make up a key, and then the key points to this many values, and the value points to this data, and so on. So what we want to unpack just a little bit more is the stuff that is in the header, because the header is where we'll find the primary and secondary sequence numbers, the signature and the major and minor versions, where do we find the first cell, and so on. So the header, this isn't a complete list, but the header is going to contain information as listed on the screen there. Now I have on there in the second bullet point is the primary and secondary sequence numbers. Those are what we're going to use when we talk about the concept of a hive being dirty. So if those two primary and secondary sequence numbers don't match, then we have a dirty hive, and then we need the transaction logs to be able to replay subsequent data that isn't in the primary hive over top of the bytes that are in the primary hive to make sure that we have the most up-to-date picture possible. Now, one of the things, the reason why we want to do that is with changes, and Dave Cowan on the Forensic Lunch has talked about this, and Maxim's work that's come out recently, just that the way that Windows is now basically caching this change for some unknown period of time, and we don't know when it actually gets flushed and persisted back to the primary hive. So as a result, if you've ever tried to do any testing on anything in the registry, AM cache or otherwise, you may not see those reflected directly in the hive. And so we want to start accounting for and pulling in all of the transaction logs along with the hives. So with that said, you're going to want to collect the hive itself and then the log1 and log2 files that go along with that particular hive. Registry Explorer was the first of the tools of mine that were updated to support transaction log replay. And then over the week, well, last week and then over the weekend, I updated the rest of my registry handling tools, and now they are all log file aware. So if you use Shellbags Explorer and you're using version 1, it's going to tell you, hey, this hive's dirty, I want the logs before it's going to process things. Now I'll talk about how you can get around that if you just don't have the logs and you still want it to load. It involves a little bit of manipulating of the hive itself, but it's not very difficult to do. Essentially what you would need to do is load your registry hive in a hex editor, make a copy of course, and then basically you want to make the numbers at offset 4 and offset 8 be the same. If they are, then the tool won't treat it as dirty. Now with that being said, If you do that, it will load into tools, but data may not be 100% accurate, of course, because it's sitting out in the log. So that can be done kind of as a last resort, but if you have an image, if you're doing live collection going forward, make sure that you're pulling in the log1 and the log2 files so that you can take advantage of the automatic processing of the tools to be able to do those things for you. So this is what it might look like on disk. And there's our chunks of data that we had on the previous screen, and there you can see at offset 4 and 8, we have sequence numbers. Now in this particular case, for this NTuser.dat hive, those sequence numbers match. So this hive would not be considered dirty, and as such, the logs don't really matter. Now there could be information in the logs. If you looked at it in a hex editor, you could parse out the HBINs and all the individual keys and values to maybe look for previous stuff, et cetera, but from a, I need to replay these things on top of the primary hive, we don't need to do that when the sequence numbers match. Now compare that to this screen. This is basically what the header would look like inside of Registry Explorer when we go into the technical details view for any given key. And we'll walk through that when we actually get in there. This is a different NTuser.dat hive, but notice in this particular one, it shows us that the primary sequence number is 900 and the secondary is 8FF. So when this hive gets loaded into Registry Explorer, it would warn you, hey, this hive is dirty. Do you have the transaction logs for us to replay? And then everything goes smooth accordingly, which we'll do at least one time, one or two. I have several hives that we'll load here and play around with as we go. So that takes us to these log files. I mentioned it a little bit, but what is it? What does it look like? Well, as the registry changes, this is basically where all of those changes get staged before they get flushed back down to the primary hive. And so if you look at these things in a hex editor, and we'll see a snippet of one here in a minute, you're basically going to have a fragment of the header, and then you'll have a list of, essentially a list of these HVLE blocks. And then inside the HVLE block, there's basically a list of offsets and sizes, however many pages there are. So you have to run through that list. There could be 2, there could be 80. It just depends. After the end of the dirty pages, it's just a big running blob of data that corresponds to what you would need to replace in the primary hive. So the way you would do this is you would load the log file, you would look at the header, look at the sequence numbers, and then for each HVLE block, you pull all the dirty pages out, and then you have to figure out what bytes need to be put at those pages. So it'll tell you basically where to go and then how much data you need to overwrite when you get to that offset. Once you do that in the correct order, the hive has now been up to date, and then the only thing that you would need to adjust so that it doesn't complain about being dirty again would be the primary and secondary sequence numbers, which Registry Explorer is going to do for you. The other command line tools, of course, are not going to update the primary hive, but they will replay it, and then basically the bytes get updated in memory, and then it just makes sure that it's dealing with the most current version of the hive that's available. So this is what a transaction log might look like. You can see we have our same REGF header up there, and then we go down the offset 200, and that's where you could see the HVLE start. So on the left side, I have offset 200, and the arrow, all I did basically was scroll down more so that we can see some more stuff inside the HVLE block. And so that's all we've done here. We've just moved the slider. It's still the same offset at 200. But up there again, you can see the HVLE. So after the HVLE, you have the dirty pages, and then at some point, you'll see an HBIN start. Again, it depends on how many dirty pages you have. Once you get to that HBIN, then you need to go in and basically you're looking at chunks of data that would correspond to what's in the dirty pages list. But if you look inside the HBIN data, you can see the same types of things that we're used to seeing if you looked at a registry hive, because it is the same data. It's basically just a chunk of HBIN data that you would overwrite, lay over top of the primary hive. So we can see an NK, which is a key. We can see several of those. We can also see an SK, so here's an updated security key. LH, there's a list, things like that. So basically, this is the stuff that's changed. Now, one thing to keep in mind, and I'll show you what this looks like here in a little bit more detail. Everything in the transaction log doesn't mean everything's different than what's in the primary hive. In some cases, it might just be a couple of bytes. So if you have a 16 meg transaction log, that doesn't necessarily mean 16 meg of data is changed in the Hive. It could be a handful of bytes in 10 different places. But the way that the transaction log is getting written out, it does it in these big chunks, just the way it was implemented. So what does that look like if we were to basically look at a dirty Hive and then replay the transaction logs so that the Hive is not considered dirty, and then we diff those? What would that look like? Well, here's an example. So we have the dirty Hive on the left, and you can see there's these bytes here. The red bytes are the diff between the two Hives. On the right is the transaction logs replayed correctly. And so you can see here, this particular one, all we have, you see we have an NK. So this part right after here, this is getting into the timestamp, the last right timestamp. And so those are the bytes that have changed in these particular cells. You can see it's suggested sites here in green on both sides. Now, if I were to go into Registry Explorer and I have the dirty Hive and the non-dirty Hive, and I did this down in the lower left, if I did a search for that key for suggested sites, notice that we get one hit in each. And the thing that's different about that is the times, right? The dates are the same, but 12:42:12 and 06:39:11 would be the other hit. Okay. If we go into the non-dirty Hive and then we look at that particular key, you'll see that the bytes there or reflect what's actually sitting in on the Hive, as we see in the diff above it. And so the technical details view becomes a very nice way for you to validate what's going on, where did this data come from, and again, we'll unpack that when we get in there, but I've shown you the Hive details and the NK record view. That's one of the most powerful things to me, and this is my favorite part of Registry Explorer, is that technical details view, because it really helps you drill down into the particulars to explore what the heck's going on with this, how does this data work, where's the relationships, and so on. Okay, so we take the dirty Hive, we replay the logs, we have a current Hive. So this is more or less what that flow would look like. You've got some dirty Hive. It's made up of header and a bunch of H bins. We have log files that have updates to those H bins in the dirty Hive. And when we replay those properly, we get an updated primary Hive where everything's good. The data that's in the primary Hive plus the log files is now, we can consider that to be updated or non-dirty, however you want to look at it. It's going to have the most up-to-date current information available in there. So with that, as kind of a roadmap to what we're going to be talking about today, let's go in and take a look at Registry Explorer and look at some Hives. So on the right here, I just have some Hives, right? I've got an NT user and a SAM software, and the corresponding log files. Over on the left is Registry Explorer. So this is basically what you'll get if you were to go out to my GitHub site to download the tools and then just unzip it. Now, when you unzip it, make sure that you use not Windows. Use 7-zip, use WinRAR. If you use Windows, it will add, basically it's going to block all the DLLs, which we'll see here in a second. So all the plugins, none of them will be available. So you want to use 7-zip or something else to unzip it, or else things aren't going to work. So as far as what we have in here, the Registry Explorer manual is just that. That's basically, I want to say and that's like it's over 50 pages, but it's pretty lengthy, and it goes through all the stuff that we'll be talking about today and everything else, maybe things we won't even have time to get to. So that's something that you would definitely want to reference as you start using this tool. This is the main executable, so we'll get to that in a second. The settings directory, this basically contains all of the configuration data. So anything that ends with .layout is going to be the size of the grids, the columns that are visible, have you done any filtering or sorting. So if you wanted to basically reset everything, you can just go in and blow away the .layout files and it'll go back to the default. So that's one thing good to know. The other things like categories and general, these are going to be things that we'll walk through here as we see how do we do bookmarks and everything else, which we'll get to up here. RECMD, which we may or may not get to, we'll see what our time looks like. RECMD is basically a command line registry 8 tool that will let you load Hives, do a search, export things out, and so on. So it's, again, command line, so it could be scripted and everything else to just automate a lot of the, is this key here or not? I want to dump out this binary data and so on. So that's something to take a look at as well. If you need a tool like that. It's also built on the same thing. So it's going to do full deleted key and value recovery. It handles transaction logs and everything else. Plugins is basically a list of all the additional features, basically additional decoders beyond just like looking at values that currently exist in Registry Explorer. So you can see here, for example, it's very straightforward to figure out what each plugin does. It's registry plugin dot something dot DLL. So word wheel query, going to decode that stuff. User assist will basically unrot 13, pull out dates and times and focus counts and all those kinds of things for us in an automated fashion. Typed URLs is going to pull the times out from the other keys and blend everything together. And so that's really what plugins are for. Plugins are not really meant to just dump out stuff that you can look at in a typical key. If there's no deobfuscation, or for example, there's no ROT13 we have to figure out, there's not going to be a plugin for that. So Aries, for example, that would do things like decode the search, anything that they did a search for. So there's some that are very, very simple, like the 7-zip history. There's some that are a lot more complex, like the OpenSave MRUs and the OpenSave PIDL MRUs. Those are going to get into things looking at shell items. There's a lot more details in there. And so we'll go through some of these. Known networks, the list of all your wireless access points, first time you visited, last time you visited, Bluetooth. You can see the different types of stuff that are there. And then finally up here we have a folder called App Compat Cache. It's for nothing more than organizational purposes, but this one, of course, is going to use the App Compat Cache code that I have, and then go in when we click on that particular key and pull the App Compat Cache out for us directly in Registry Explorer. And then finally, bookmarks. This is a way for you to basically add your own methodology, if you will, your own bookmarks, your own areas of interest to Registry Explorer. So you'll see we have a common and a user folder. User is empty by default. Common has 98 bookmarks that are included with the tool. And you can see if you look at the names, you have auto runs, NT user, auto run software, operating system, control panel. Basically, these are just JSON files, so they're very simple to look at. You don't need to build these manually. I'll show you how to do one in the tool. But they're simple JSON. If you come up with a bunch of good bookmarks, you can do a request back into my GitHub repository. You can email them to me, and then we'll add them into the main distribution. So you'll see why those are going to be valuable here for us right now. So if I start up Registry Explorer, the current version is 1.0.0.1. It's a very straightforward interface. If you've done anything in registry tools before, or even just like a Windows Explorer style feel, you'll be right at home. So if we just go through some of the stuff at the top here, we of course have our help menu, which we'll get to the legend here in a bit. We've got our messages, which we'll come back to, but plugins, this is one you always want to check, because if you didn't get things extracted right, this list would be empty. Now, as you go, if I go through here and I just click through here, you can see that the plugin is going to get information pulled out of it and then tell you which keys and values are going to fire this plugin. So you don't have to invoke a plugin. It knows, as for example, as soon as I go to this particular key, it's going to add an extra tab for us, and we're going to see the data decoded. So we'll run through several examples of that as we go in here, but that's more or less what's going on underneath the plugins. We'll come back to the viewed. Now, there's no bookmarks listed here. It says 0 and 0. We're going to come back to that. So just remember, there's no 0 and 0. We have no bookmark showing, and again, we have no hives loaded. Options, do you want to recover deleted keys and values? Yeah, you do. So that's on by default. Do you want to show associated and unassociated? Probably. And I'll show you what that means here when we get some keys and values, some hives loaded in here rather. Show hidden keys, we'll come back to. Skins, if you wanted a dark theme, a Christmas theme, you could do that kind of thing. If you don't like what I give you, you could turn it into whatever you want just by clicking one of these buttons. Preferences, this is where you can change your date time format. If you wanted to add the time zone, so you always see UTC, or you don't like, you wanted to add the millisecond precision or whatever else it is. And then there's some other stuff for if you want to see the information as base 64 versus just binary, you can do it that way as well. Under tools, we have find, which we'll come back to when we actually have stuff to find. And then finally, our file menu. We can load an offline hive, one or more. We can, if you do that, you can then save a project, right? We can't save anything because we don't have anything loaded, but if you had 10 hives or 8 hives from a particular computer that you wanted to go back to, you could save that and not have to figure out, I don't remember which hives I loaded. It would do all that work for you. So let's go ahead, and the easiest way I think is just to drag in one of these hives. So for example, if I just pull ntuser.dat in, it can go anywhere, but I usually just drop it here. The first thing it's going to tell us is, hey, wait a minute, the primary and secondary sequence numbers don't match. Now, Registry Explorer has done that for a while, except prior to version 1, it would just tell you as a message in the messages window, hey, this doesn't match. But now, because of new research and everything else, we force this now because it's just such an important thing to do. So it tells you what's going on. Do you want to replay the logs? Yes, we do. So if we hit yes, it's basically going to walk you through the steps in order to do that. So in the following dialog, select the transaction logs you wish to replay. So we hit OK. It's going to take us out to where we need to go. And you can see we've got those. So we hit those. And now what do we have? Well, we've got transaction logs have been replayed. And in the following dialog, select a location to save. So for this particular one, I'm just going to go out and save it to a different name. It doesn't matter what you call it. It doesn't matter where you put it. The fact is that we're just dumping this updated file with the transaction logs replayed over top of the original Hive that we had. So once we do that, you can see that it's going to give you a warning, a message that says, hey, I've updated the sequence numbers. And it does that. So again, we don't continually get hammered with the Hive's dirty, the Hive's dirty. So at this point, I can go ahead and load this Hive. Do I want to load the updated Hive? Yes. Do I want to load the dirty Hive? Sure. And it loads in. And at this point, we can now start looking at different things. So here, what I want to point out really quick, let me just make this a little bigger if I can. Let's see which one. This one here is the one that's been repaired. It shouldn't make much of a difference. But what I want you to start noticing now is look how things have changed. First of all, in the registry hives, it says 2. So that means we have 2 hives loaded. We're going to come back to this available bookmarks. As I move around different places, you can see that these tooltips start coming up that kind of give you a little bit of a quick help about what's going on here. So we're going to come back to that. But notice now under bookmarks, it tells me that there's 24 available. It says 24/0. Well, the 24 means that I have 24 common bookmarks and I don't have any user ones, so it's 0. But now notice what this does when I go in here now. It now gives me a list, and remember there was 98 or 90 bookmarks, something like that, total in the list when we looked at it from a file system perspective. So what we're seeing here is only the 24 bookmarks that actually exist in this Hive. So for example, if I were to click on Common Dialog, COMDLG32, it's going to jump us out to that key and expand it. And so you can see we have all the different keys. It just basically unrolls us and then selects us down to this point. Now, if I wanted to expand out further, of course I could. And you can see I've got these different things. Now, remember from here, I had plugins that dealt with CID size MRU and last visited MRU. Now, there's some data in there. So if I were to click on one of these, notice what happens. Now, I have this tab. We're going to come back to that. But if I click on one of these keys, you can see this column is the number of values, number of subkeys, and then the last write time of the key. So if I click on that, notice we have our values in here. We've got an MRU list, and then we've got 0, 1, 2, 3, and 4, and then a bunch of binary data. So 0 value is selected, and so you can see here's all my data for this particular key, which is of type reg binary. There's also some slack space, so anytime there's slack, you get another viewer that basically will show you the binary view of all the slack. If I were to switch, it's of course going to switch to whatever's in there. Okay. Now, sometimes you may find that you want data out of here. So if we were to go in here and highlight some bytes like that, you can right click and copy just the hexadecimal characters. The string is ASCII, or the bytes is ASCII, or the bytes is Unicode, and it's going to put that on your clipboard. You can put it in a report, whatever you want to do. So there's context menus available for the hex viewer. We're going to come back to some of the other stuff here in a minute. But let's talk about plugins here first. So notice if I go to Common Dialog again, there's no extra tab. But as soon as I click somewhere where there's a plugin, it shows up. And notice what it did. It basically has gone in and pulled out all the details that are of importance to us in the right order. So it basically, by MRU position, it pulled out the text. And you can see here, there's an example, notepad.exe. Well, it pulled that out, it knows it's at MRU4, and then it can figure out the opened on based on the newest one and the last write timestamp. So it's going to do a little bit of analysis for you and pull out, and this is a very simple one, but as we'll see here in a minute, some of the other ones can be a lot more complicated. Now, before I go and click on another one of these, let's take a look at some of the other areas of the interface here that can be of use for you. So down here at the bottom, of course, it tells you the current offset in the hex and the bytes selected. That's good. There's a data interpreter that we'll open up here in one moment. But let's take a look at the status bar down here, basically the top status bar and the secondary one. So this is the key that we're currently looking at. Now, there's a bunch of ways to do these things, but you see the tooltip is going to tell you, hey, if you want this key copied to the clipboard, you can just double click it. And so if you wanted a quick way to get the key out, you can do that. If you wanted to get the last write timestamp, you can click on the last write timestamp, double click it. If you want the value name, you can click on the value name over here. This collapse all hives we'll do in a little bit later when things get a little bit messy. So you can see you've got some information going on down here that helps you whenever you have more information going on. You may want to potentially get that out. Now, when we talk about the context menus, we'll see additional ways to do that, but that's the quickest way to get some of those things out of there for you. Now, the last thing I want to show you is down here we have this yellow box, and the reason why it's yellow is because in the messages view, there's been some warnings. So you can either go to View Messages, you can hit Control-M, or you can just double-click that, and it's going to bring up the Messages window. And so here you can see what it was doing. Hey, the hive length is smaller than this. The sequence number is dirty. Basically, it's just telling you what it's doing as it does its work. And so anytime there's a warning, you can see now it's not yellow anymore. Why? Because we viewed the messages. It's going to show you in yellow if there's ever been a warning. If there's an error, well, that's going to be shown in red down here. And of course, an error is going to be worse. And that could be something like it couldn't parse the hive's damaged for whatever. Registry Explorer is very particular about what it wants to open. It's not going to just do a best effort to try and open stuff up and certainly not just then not tell you about it. It wants things to be correct so that you at least know that, hey, there's a problem here, and you have a chance to correct that versus, well, I'll just do what I can and hope for the best kind of an approach. So if I close the messages window, we can get back to here. Now, this is a pretty boring example just because of this data is pretty empty, but let's take a look at the data interpreter. So if I click data interpreter down here and I click this, notice what we have going on here. I've got a list of numbers, 8-bit signed, unsigned, 16-bit, 32-bit, etc., dates and times, GUIDs, IP addresses, strings, base64 data, and so on. If I click somewhere else in here, this is going to update to reflect where I'm at from the position of the cursor forward. So, for example, I'm going to do that, but I'm going to toggle this always on top. If you have a multi-monitor situation, that you really don't need to do that, but if I don't, I'm going to have to keep toggling back and forth. So if I click on offset 0, notice it decodes this Unicode value for us, Notepad. ASCII, of course, is just N because there's a null character there. And then you can see all the numbers and the dates and everything else. But as I move this around, notice what it's doing. It's going in and from wherever the offset is forward, it's figuring it out. It has absolutely nothing to do with the bytes that are swept or selected. It's the position of the cursor forward, the relevant number of bytes. And so that just depends on what's being interpreted. And so this becomes a very nice way to start doing reverse engineering of things. Maybe you have some suspicion there's some dates in there. Well, I can just start moving my cursor around and have these dates pop up. And oh yeah, there's one, I remember doing this, in my testing, I was doing this last Friday, and there's the date. Whatever that looks like, it's going to let you go in there. Now this particular one doesn't have any GUIDs that are actually going to map back, but you can see here this particular one calculated it. Just like Shellbags Explorer, this tool is aware of how to convert GUIDs to human names. So if it has a GUID that it knows about and there's several hundred in there, it would tell you, oh, that's the control panel, that's Dropbox, that's HP printer, whatever, as you click on these things in different places. So we'll come back to this. This is when we have a little bit more data, but you can see we've got to and from base64. There's lots of interesting things you could do just for like data hunting in here to figure some stuff out. So we'll turn that off for now. If I were to do another plugin here, another one, basically the same idea here. these start looking a little bit more complicated now. So you can see here, we have a bunch more stuff going on. We have binary data still. This is the raw values. But here you can see we've got extension blocks and some other things going on, much more data. And depending on what kind of a key and a value you're looking at, you might have plenty more going on in there with shell items and everything else. But again, the plugin is going to do the decoding for you. And here you can see we pulled this absolute path out. Well, it's doing that by going in there and decoding the GUIDs and everything else from this stuff in here. Okay, so this is a good example. If we were to run around in here, here's a beef extension block, a beef 26. There's probably some other ones in there too. If we were to roll this again, and here, let's see if we spot the GUID, wherever it is. One of these will start resolving back. But this is more or less how you can do it. If you're kind of trying to figure something out, there it is right there. So at offset 1C, now I know I could tell you by looking at this, this is a 1F. So this is a shell item, like Shellbags Explorer would do this. Here's where it starts. It's 14 hex bytes long. The type's 1F. The 50 is just another value, like a flag. And then right here at this offset, 16 bytes, there's my computer. So we could keep going down that list, and you can see it's doing that work for us here. We didn't have to do any of that, which makes it nice. Okay, and that's the whole point of this, is we can validate what the tool's telling us directly in the tool if you didn't want to have to go out and try and figure out all these things on your own. Now, all the plugins, if they work, everything works great, you're good to go. If there's an error, if something couldn't be parsed, if there was data it didn't understand, you're going to get a little drop down here that says errors. You can also, there's a tooltip over here. It basically tells you what the plugin's doing. But we can also export anything that we see right here directly out to Excel, which is nice because then you have the data in this format as opposed to this format. You can do whatever you want. Now, if you've used any of my other tools, you can do filtering on any of these grids as well. So if I were to go into the executable and just start typing something, you can see it's going to match us down to whatever matches. We can edit the filter and turn it on and off. You could do grouping. This isn't, well, we could do one group here. If I group by absolute path, for example, notice what it does for us. It's going to roll up and tell us there's 4 things in this path, and there's 1 thing in this path, and it helps. 5 isn't that big of a deal, but when you have stuff with hundreds of things in there, grouping and seeing the counts can really make your life a lot easier. So that's more or less how plugins are going to work. And so you can see there's another one. It's just going to dump all these things out. Now, this is, and I'm not going to go through a ton more plugins here. We may at the end. But what I want to explain here on this one, because it really helps. Notice this particular one has 4 subkeys. Well, I can click on each of the keys and get data out of there, but I wouldn't want to have to do that for each extension. If there was 10 or 100, that would get old really fast. So at the root level, when we click on the parent key, it's going to go through, and for every extension and every key or every value in each of these keys, it's going to go in there and do the work for us to rip those things right out of there, and we're good to go. So again, it just saves you time from having to deal with a bunch of these subkeys to do things. Now, up here, if I go back to values, let's see, pick one that actually has some values in it here. You also can do things with this the particular data that's underneath here. So there's context menu for values. So I could export out the slack or the data as binary in this case. I can copy a summary to the clipboard or the name, data type, right? So this is how you would do this manually as opposed to double clicking. I can also invoke the data interpreter directly on this value. So if I were to just say data interpreter, it's going to dump that out, and you can see everything that we saw earlier. These particular ones aren't the best examples, but when you look at strings or you look at like a Q word, which is just basically a 64-bit timestamp, how it's going to be in there, you could use the Q word if I didn't have a plugin, and it'll tell you what the time is. So rather than copying the bytes out to decode or something else, you can just do it right in the tool. And if you want to get it on a specific value, even if it's interpreted as non-binary, you can just use the data interpreter here. So that's a very useful feature that was added several versions ago. Now, we also have shortcuts on the keys themselves. So if I were just to stay on the same key and right-click, notice I can add a bookmark, which I'll do in a minute. I can hide a key. I can export out a key to .reg format or recursive, which you could then pass off to somebody else. They could import for testing or whatever. We can copy the key name, path, or write time, same as we did double clicking down here. Expand or contract our subkeys. Now this one's expanded, so it's grayed out. And then our technical details. So let's take a look at some of these here briefly. If I were to go here and then right click, you could see expand works, and it would open that up for me. And then I could collapse. There's shortcuts as well. Okay, so if I wanted to make a bookmark though, for whatever reason, now that one I already have, but let's just say we go down here to user shell folders for whatever reason. That to me is of interest. So if I right click and I say add bookmarks, I can go in and pick a category, and it comes with a bunch of them. If you want to add your own, just type it in. But we'll just say operating system, and then a short description and the long description, or whatever you want to refer to it as. And we'll see how that gets reflected. So we'll just say shell short desk and shell long desk. Now, if I hit save, what I want you to notice is watch what happens to the bookmarks view. It says 24.0 right now. Well, now it says 24/1. Why? Because we just added that in there, and you can see where the description comes into play. If you want to see all the bookmarks or edit them, there's a manage bookmark view where you can go in and change the descriptions. There's the one we just did, and so on and so forth. You can delete these, whatever else you want. If we go look on the file system now, we would have a new JSON file with that particular bookmark in it. Okay. So again, if I were to go in here, I'm going to do one more, and we'll just do this applets just because I want you to see what's going on. Applets. You don't need a long description, but again, things change. We have bookmarks, and then we have available bookmarks. Now, if I have multiple hives loaded, and I do, right? I have this clean hive and the dirty hive. Notice that if I wanted to click this one, I then can go into bookmarks and jump down to that. It's going to find it for me. But look at all the stuff that's in the way of me trying to figure out to get to applets, or to get to common dialogue, or to get to user assist, or whatever I'm interested in. I have to go through a whole bunch of stuff to get there. There's a lot of noise here. So what available bookmarks does, take a look at this. There's 7-zip, applet, CD burning. Look at the words on the left here. Okay, and then look at them here, user assist and applets. Now watch what happens when we click available bookmarks. Notice how the view changes so that the root key that the bookmark corresponds to is now our top level key. And if I click on that, there's my values. This is everything underneath applets. This is everything under common dialogue. So rather than me having to go bookmarks, common dialogue, click, 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 I can just go to available bookmarks and start selecting these things right off the bat. Now, as I go to these, down here you'll see that the bookmark information changes. And if we get down to the bottom, you'll see that we have 2 of them that are in a dark blue and bolded. Well, the blue means that it's a user bookmark as opposed to a built-in one, a common one. And how do you make a user one a common one? You just move the JSON file from user into common, and it's a common one now. So that's a really nice feature that you can use to go in there and do those kinds of things to very, very quickly look at a ton of different data. So that's nice. Now, let's say I'm going to load another hive in here. We'll just do this one and this one. Now, I don't have the logs for that, so we're just going to leave that dirty. Yes, I do. And then I want to get a user class and a system. Just getting some different hives in here. And now what I want to show you is, watch what happens now. So I have NT user hive selected, and I have 24 and 2. But as soon as I switch to a different hive, let's try the D Blake NT user. Notice it changed to 26 because there's 26 bookmarks available in there, only 24 in the other one. If I were to pick user class, it gets way down, right? You're going to have really shell bags. So there's what our shell bags would look like purely in the registry. Now, if I wanted to, I could go in here and do a bunch of stuff, but look how much noise I have in here. Well, that takes me back to this collapse all hive button. If I want to get things back to my starting state, I can click that and things get sane, and I can go back and look at what I want. So user assist, or user class rather, had 2. System has 27. And you can see all the different stuff that's in there. And again, if I were to click any of these, it's going to jump us right to that particular one. So for example, time zone info, there's a plugin for that, and it just decodes everything. So that's cool. If we collapse this, I want to talk about some of these other virtual keys here. If I expand out some of these to a degree, let's see how many we have to go. There we go. I want to bring up the legend. And so as you navigate through the tool, you'll see icons, and the icons will have different overlays. So you can see there's the green registry one, there's a little triangle. Well, that means that hive's dirty, which is why I loaded some dirty hive so we can see what that looks like. You can also see that we have a normal registry key. We have a registry key that's been deleted. I haven't talked about hidden, but we'll do that in a minute. I also have a placeholder, associated and unassociated from deleted keys. Now, what does that mean, associated versus unassociated? Well, as we recovered registry stuff, keys and or values, we can go and look to see if those keys point to an active other key, that's parent key. And if we can find that, we can basically reattach it. So the nice thing about this is, if I were to go down into here and then software, that's going to be Microsoft. Let's see what it is. Software, Microsoft, Windows, Office 15. Oh, did I miss it already? No, just Office. How about we just do a search? But I don't want to waste any more time talking about that. If we drill down in here, what you're going to see, and we could probably just do it this way. Let's do it this way and see if it works. Expand. What you're going to see inlined in this data is the deleted keys that were recovered. But as you can see, I'm potentially having to wade through a ton of stuff to try and find those keys, and there they are, at least some of them. It would be horrible if you had to go try and find all the deleted keys buried down in who knows where. And so what this is doing is, it's going to show you, yes, here's where these keys existed in contrast, in reference to the parent path and everything else. But if we go down here again, and I looked at this associated stuff again, and let me just roll this up. Notice what we actually are able to do here now. It's going to go in there and build out those placeholders. All those keys exist, and then here's where the keys start being recovered and attached to. So that's what the concept of a virtual key is. This key exists, this exists, this exists, this exists. These are the ones that were deleted. So if you went to this path, you would see these hanging off of there. But this provides a way for you very, very quickly. If I were to just collapse this and open it up, there's a way for you to see where all of your deleted keys live in one single place, as opposed to wading through thousands of keys trying to find them buried down in the muck. Now you could do searches and everything else, which is what we're going to start talking about next, but that will certainly make your life easier. So the last thing we'll talk about quickly before we go into searching is the concept of hiding stuff, hiding keys. So over time, and you can probably already see this on the screen here, there's some keys that are they're not very useful. And so there's ones like I've never found anything useful in console. I've never found anything useful in app events, whatever your case is. Well, maybe you want to not look at those because they're just noise and you have to deal with them. So if you want to, you can hide that either for the session or basically until you remove it. So watch what happens here for this NT user hive. I have app events here, probably up here as well. If I create or hide this key, and I'll just do it for the session, watch what happens. They're gone. Okay, I could do the same thing with console, they're gone. And so it's going to remove noise, remove junk from your view that you don't necessarily care about. If you want to see those, you just would go in here and toggle that, and you could see now that it has that little red dash in the corner. Well, that's going to be ones that have been hidden. And if you wanted to unhide them, this is session only. This would only be the persisted ones. I didn't do any permanently, but if I did, I can go in here, right click, and delete it. Okay. Now, these would be shown again as soon as I restarted Registry Explorer. This is just like for the session. It's not going to happen every single time. So if it is something you want to do, you can do that. And then, of course, you just can toggle it with the Show Hidden Keys option. So that takes us into the searching, which is where we'll probably spend the rest of our time here. We want to look at finding, and so we're going to talk about this dialog, and then we'll get into the technical details view with any remaining time here. We got about 10 minutes before I want to leave some time for questions. And so this is our find dialog. And so this is really where one of the very capable features of the tool is. One, you already see we have a bunch of different hives loaded, 6 here. I've had 80 hives loaded. I've had people tell me that they've had a gigabyte of hives loaded and they can search through this stuff and it's fine. So this is really where things start making a lot more sense to be able to do things at scale, find things across a multitude of places without having that one hive at a time kind of an approach, which is what we had to deal with for a long time. So again, we have help. We've got options, which we'll talk about here in a minute. But basically, there's 3 sections here. We've got a standard last write timestamp you could do before, between, after, and it'll filter things down by that. And then the minimum value size and base64 encoded value search, which we'll get to those here in a bit. So let's just start with the standard search. You can do regular string searches or you could do regular expression searches. It's up to you. But let's just say I wanted to do something like putty. And then I wanted to do something like suggested, spelled correctly. And then we'll do something like SITES. Now notice how I have that capitalized. So these are all lowercase, but that one's all upper and lowercase mixed. And you'll see why we're going to do that here in a minute. So I can search in key name, value data, or Slack, either individually or all at the same time. Key name is the fastest, value name is slightly slower, value data, of course, is going to be even slower, and then all of it is going to be the slowest. Why? Because it's going through a ton. So for these 6 hives, if I were just to do those searches and hit search, it's done. It took 0.00284 seconds to do a search across all those hives. So here you can see the hive that it hit in. You can see that these are all key name hits, of course, because we have this. Now, but notice what happens if I were to go in here and just double click on one of these. It's going to jump to the hive where the hit was. It's going to go to the key and then show you the context highlighting of what that hit was. Notice that it was sites uppercase and lowercase here, but of course it doesn't matter. So searching in Registry Explorer, it does not care the encoding, if it's ASCII or Unicode. It does not care the case. It's not case sensitive. It's going to find the stuff regardless. Okay. So you can also group by hit text, and there's a nice another thing with your value count or your counts. You can go in there and see all the different places and so on. So if I unroll that, now I'm going to switch from key name to value data, and it's still relatively quick, 0.8. Now these are all just regular hits, but these are going to be in value names. So watch what happens if I just double click one of these. It's going to go to the hive, go to the key, go to the value, and then select it for us. And you can see this one right here, desktop putty, is what's selected. If I do it in data, it gets a little bit more interesting because now we're potentially finding binary data, string data. You can see it's taking quite a long time to compare to the other searches to actually find things. I don't have to wait. I can go in here and just start searching. It took 13 seconds to do a values data search across all those. So now you could see that I have some hits here. If I were to just double click this, watch what it did for us now. It selects the hive, it selects the key, it selects the value, and then it highlights the bytes that make up the hit for us. So there's our putty hit, for example. So you can see there's all the value names and everything that's going on in here. Here's site, for example. It's going to, if it's a string, it's going to give you the context highlighting of the string that it hit in here, and so on. Now, one thing that a lot of people do, especially depending on the types of investigations, is they want to find executables. And a lot of times you might find interesting executables in something like user assist, which is ROT13 encoded. Well, find is not going to do any kind of interpretation of that data for you, but what you can do is just type your string in, whatever you're interested in. You have a particular piece of malware you want to look for. I can highlight that and go options, convert, and then say ROT13. And now it's going to be ROT13 encoded, and we could see if we actually find that out there anyway. I have no idea if this is going to be found, but it's a way for you to go in there and look for obfuscated things without you having to go out and figure out how to ROT13 it, which again, if I ROT13 it again, boom, we're back at our starting point. So it makes it quite nice to do those kinds of things. So search can be extremely capable. We, of course, could do all these things at the same time. It's going to take a little bit longer. We'll just do one here and see what we get. You can see you get quick results back for some of the things. Some of the hives are, of course, going to take longer. It just depends on how much stuff you have loaded. Again, the person that has loaded a gig of hives, I think he mentioned it was taking like a few hours to search through all of that data, doing pretty much everything. So it can be very, very quick for you. And if you don't have a GigaHive loaded, it's going to be that much faster. So for most stuff, it's going to be just a couple seconds and you're going to be in good shape. Now, the other things I want to show you real quick is this minimum value size and base64. And so if you think about the whole fileless malware, and we're going to stick a bunch of stuff, executables in the registry, and then we'll get them out of the registry. Well, they're going to try either to encode that somehow, they have to put it in the registry, some value in a key. Well, those things are going to be abnormally large, bigger than you'd expect, bigger than what's normal. And so if we can have a way to go in there and find abnormally large values, that might give us a very, very good way to find interesting stuff in a registry hive. So all I have to do is put the minimum number of bytes that I want, say 50,000. I hit search and it's done. I get all my hits back. You can see that there's one with 982,000 bytes and then 500 or 54,000, 53,000, whatever. If I were to click on any of these, it's going to take me right to it. And there's my past icon streams. There's the data that was that big. Okay. You can also see we have a bunch of slack space there. This one's rather boring. It's all zeros, but you get the idea. We can go in there and make a lot of interesting discoveries relatively quickly. So there, you'll get used to seeing some things that are false positives like icon streams and past icon stream. But the other stuff that comes out generally will be pretty interesting if you have something of that kind going on. Same thing with this base64. I could put in, let's just try 20,000, see if we get anything, and we'll lower it until we do. The idea there is we're going in looking through things to find base64 encoded data. And if we find some, we can go out there and just jump to it. Now, caused the problem, unhandled exception. I'll fix that. So this doesn't guarantee that this is actually going to decode to some, it just solved the case for me. What this is telling us is that all it means is that the regular expression for base64 encoded data, this string passed it. So from here, you're going to have to do your due diligence to start trying to unpack it and figure out what's going on. But this particular string is base64 encoded, and then you could, of course, go from there to try and make some sense out of it. So that's more or less hitting the highlights of fine work. We're kind of running low on time here. I would definitely recommend playing with it and looking through the manual. There'll be a few more nuances in there with how to do groupings here and make your life a little bit easier with, it tells you if they're in deleted space or not, and so on. So the last thing that I want to go through here quickly, and let me just find a decent one here. This one's fine. I want to talk about the technical details view because we brought it up at the beginning. So to kind of come full circle, let's take a look at what's going on here in the technical details. So you can either hit F5 or right click and say technical details. And now this is going to tell us everything that there is to know about the data that makes up a key, the values, the security record, and so on. And so, for example, you can see down here are the bytes. If we looked in a hex editor, we're on the browser emulation. Those are the bytes that live on disk that I need to interpret. And so up here you can see it's all broken down for us. And if I was interested in, well, where are the flags? Well, they're at offset 6. So I could go out here and go 1, 2, 3, 4, 5, 6. But if you just click on that, it's going to jump that and highlight the number of bytes that make that up. So if you want to know where your last write timestamp is, there it is. If you want the signature, there it is. Okay, so it's going to do all of that stuff for us. Where's the name? It lives right there. Where's the length? Right there, and so on. Okay, so all these different things, all you have to do is click on it, and it's going to tell you what's up. Okay, so you get the 13. It tells you where it is in there. And now notice up here, we've got an NK record, which is our key. We've got values, and so there's all the values. If I move this over, there's all of our values here. And so if I were to click on this list one, there's what a VK looks like right there. Now this is a resident one because it's a D word. So you can see it's resident, it's checked, and that data is actually going to be, that's the value. It's going to just live in there where the data is, everything else, it's going to just click on that and pull the data out, whatever it is. There's our data right there. That's where it lives. That's where the flags live in this particular one, and so on. So I can look at all the values, and it's showing me the raw data that this interpretation is bringing up. Okay. Now for the ones that are binary, for the ones that are binary, like the YMD here, Notice that we get value data comes up. We get the hex view because it's hexadecimal, it's binary, and then we get the slack. So it's going to pull those things all in the view here for us, and you can do the same types of stuff that you saw before. Here's a list of all our subkeys. I can double click any of these and it would open up another technical details view for me, and we can do the same type of stuff. Here's a security key. Now the SK key, you can see there's not a ton of bytes there, but there is an absolute ton of information packed in there with all the DACLs and the ACE records and so on, the SIDs and what the groups mean. And so you can go in there and start drilling down into where all this individual stuff is and have an understanding of how that stuff works, where it lives, the forward links and the backward links, and how many times it's referenced, and so on and so forth. If you wanted all that stuff as text for a report, you can click on that, copy all this stuff out. And then again, we have our Hive details, which we saw, this one being the example where they were dirty from our presentation. And so that is basically a relatively deep dive with the time we have of the functionality and the features in Registry Explorer that are going to help you find data faster and help complete, have a much better picture of what's going on in your cases by use of bookmarks, by use of plugins, and by use of data recovery, and then finally by the ability to replay transaction logs. So that leaves us right 4 or 5 minute mark. I wanted to make sure we had some time for questions, so I'm going to turn it back over to Carol to see if we have any questions, and if we do, we'll get them answered.
All right, well, thanks for that great presentation. We do have a couple of questions ready for the Q&A. However, if anyone has a question for Eric, please enter it into the questions window now. Our first question involves hide keys. Does this functionality only hide matching keys at the same level, or does it hide all keys no matter what level or nesting they're at?
It's only going to be at the nesting. So for example, if I were to hide environment, it's not going to blow away every key that says environment. So it's smart enough to know what hierarchy it lives in. I believe that was they wanted to know whether it was everything or if it was smart enough to know the hierarchical structure of the key. It is hierarchical.
All right, thank you. How do you get a report out of this tool with all the items that are of interest to me?
That's one of the things that's on the roadmap as far as me building a right-click add to report. It depends on the nature of your case, what you're trying to show. Most of the time, at least in the kind of work that I'm doing, at least to this point, if I'm doing something with a key, I might document keys and values and then type up some type of narrative summary or do a screenshot and so on and so forth. If there's several things from different bookmarks and I want to just make a report of 5 keys that I've added to a report, that type of functionality does not exist yet, but it's something that is planned for an early, it's sooner than later, but the idea there being you could right click and add a key to a report, and then when you generate the report, it would pull all that data in and give you some type of a summary. The trick with that is, with all of the different types of data, how to display and make that work in a way that isn't kind of overwhelming to the end user, to the consumer of the report. So I'll probably throw out there to get some ideas from people how they want to do that when I get started on how to actually build that in there.
All right, thank you. How do you list out the registry that's added by running an exe on the system?
Can you say that again?
Sure. How do you list out the registry that's added by running an exe on the system?
Yeah, I don't understand the question exactly. It sounds like, do you want to know where to look in the registry to find which executables have been run? There's several places. You can load AM cache Hive for certain. There's some other keys in here like the BAM and the DAM keys that have been recently discussed that would show you the executables that have been run. So from an evidence of execution perspective, you could do things like app compat cache as well. So for example, if we went down to system and did app compat cache, there's a list of all the executables that have been shimmed in one place. And this one has 546. And so that would be one way to see all the executables. Hopefully that was the gist of the question.
All right, thanks. I'll see if they clarify or if you've answered it. Does the technical details view have a save on top option so it remains when you go back to the Reg Explorer?
It does not. I could certainly add one, and if we need one, I can add that in there for the next version for sure. Usually, at least on most forensic systems, you're working with multiple monitors. In the case that you aren't, I can see how that would be a pain. So I will make a note of that and have that in for the next version.
Can you provide details on how to fix a dirty Hive if the transaction logs aren't available?
Sure. So essentially what you're going to have to do is get your favorite hex editor, load in the Hive in the hex editor, and then go to the offset 4 and offset 8, and then make those numbers match. That's it. So if I were to go into this particular Hive and then change the secondary sequence number at offset 8 to be 0612, so they both were zeros the same, Registry Explorer would consider that Hive not dirty anymore. So it's very, very simple. I could certainly elaborate on that on a blog post or something, but it's literally just making the bytes at offset 4, the 4 bytes at offset 4, match the bytes that are at offset 8. They just have to be the same for it to be considered not dirty, at least as far as this is concerned.
All right, thanks, Eric. That's all the time and questions we have for today. We really appreciate your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.